Today we'll be looking at JUPEB mathematics questions. Our question 1 says, evaluate the limit x tends towards 0 of tan 3x over sine 2x. Alright, in evaluating this, first we would understand that tan 3x would give us sine 3x over cos 3x. Now rewriting this, imputing this for tan 3x, we are going to have our limit x tends towards 0 as sine 3x over cos 3x times our sine, since it's all divided by sine 2x. Okay, if we do the inverse of this, we are going to have it as sine 3x over cos 3x times 1 over sine 2x. Okay, now bringing this together, we can rewrite this to become sine 3x over sine 2x times 1 over cos 3x. Now it is important to know that if we should factorize this, we are having it as sine x over x, which will give us 1, sine x over sine x, which is 1. Okay, so if we have sine x over sine x, which will give us 1, so this we can rewrite to be sine 1 times 3 over 2, moving our signs, times 1 over cos 3x. But in trigonometry, we know that 1 over cos 3x is also giving us 1. So imputing this for this, we have 1 times 3 over 2 times 1, which will give us 3 over 2. So our answer is A, 3 over 2. Solve for x in log 2x plus 3 plus log 2x minus 1 equals 3. Now, in solving for this, if we use our multiplication law of log, this becomes log 2x plus 3 x minus 1 equals 3. Now, if we recall that log a b equals n, so therefore our b equals a raised to power n. Now, applying this law here, we are going to have this as x plus 3 x minus 1 equals 2 raised to power 3. Alright, opening up these brackets, x times x will give us x squared, x times minus 1 will give us minus x, 3 times x will give us plus 3x, and 3 times minus 1 will give us minus 3, equals 2 raised to power 3 is 2 times 2 times 2, which is 8. Okay, now if we collect like terms, we have x squared, 3 minus 1 will give us plus 2x minus 3 equals 8. But now let's move our 8 over to this side. 3 will become minus 8 equals 0. So our equation will become x squared plus 2x minus 11 equals 0. Now we are going to solve out this equation using our quadratic formula, which says that x equals minus b squared minus b plus minus root b squared minus 4ac all over 2a, where our a is 1, b is 2, and c is minus 11. Now imputing these values for this, we are going to have it as our x equals our minus 2 plus minus root 2 squared minus 4 times a minus a is 1 times minus 11, which is c, all over 2 times 1. So this will now give us minus 2 plus minus root. This is 4 minus, okay, 4 plus 44. 4 times 1, 4, minus times minus plus times 11, 44. So this will give us all over 2. So from here we're having minus 2 plus minus root 48 over 2. Now, if we solve this out, we're having minus 2 plus minus root 48 will give us 4 root 3, okay, over 2. Now, how did we get 4 root 3? Root 48, okay, we look for, that will become 16 times 3, okay? 16 times 3 will give us 48. Now we know that root 16 is 4 and root 3. So 48 will now be 4 root 3. That's how we arrived at 4 root 3. Now having done that, we can now simplify this. What's common here will be 2. This will become minus 2. Okay, let's factorize it. This will become 2 bracket minus 1 plus minus 2 root 3 over 2. So this will cancel this for our answer to become minus 1 plus minus 2 root 3. Alright, this will be our answer. If f of x, fx equals root x squared plus 1, find derivative of fx. Now, in order to do this, let's change this to fx equals x squared plus 1 raised to the power half. Since we know that mathematically our root sign is raised to the power half. Okay? So now, if we differentiate this as a unit, our dy dx here, our d dx here will become half bracket x squared minus plus 1 minus half. Now if we differentiate what's in the center here in our bracket, our x squared plus 1, if we differentiate it, our d dx for this will become 2x. Okay, now bringing these two together, we are going to have it as a half x squared plus 1 raised to the power minus half times 2x. Okay, now we know that this raised to the power minus half is same thing as fractional law 1 over. So this becomes 1 over 2 brackets x squared plus 1 raised to the power half. Alright, okay, x squared plus 1 raised to the power half times 2x. So this will cancel this, leaving us with x over x squared plus 1 raised to the power half, which if we rewrite this will give us x over root x squared plus 1, which is our option A. Find the center of the circle in your equation x squared plus y squared minus 4x plus 6y minus 12 equals 0. Alright, now if we apply the completing of square method here, this becomes x squared minus 4x, half of x, you square half of the value of x and add to this, that will be 4 divided by 2 will be 2 squared, which is 4, plus y squared plus 6y plus 6 divided by 2 will be 3. 3 squared will be 9. Then add this to both sides. This will become 12 plus 4 plus 9. Okay, factorizing this, since this is squared, we can bring it out as x squared minus 2 squared. Okay, let's make it equal x minus 2 squared plus y minus plus 3 squared, which is going to give us 9 plus this will give us 25. Okay, so if we solve out for this, our x minus 2, okay, equals 0. So therefore x equals 2 and y plus 3 equals 0. So therefore y equals minus 3. Okay, so our center for our equation is center of the circle will be at 2 and minus 3. And if you ask for the radius is root of 25, which will be 5. So the center of our cycle will be at 2 and minus 3. If A equals 1, 2, 3, 4, it says find the inverse of A. So our A inverse is what you're looking for. In order to find the inverse of A, we'll first of all find the determinant of this matrix. And for our determinant, we are having it as 1 times 4 minus 2 times 3. Okay, which will give us 4 minus 6, which will give us minus 2. So our determinant is minus 2. Now, if we want to solve for the inverse, for A inverse, we will use 1 over our determinant times our matrix. Okay, we have this matrix as A, B, C, D. Okay, now we'll swap our matrix. For us to find our inverse, we'll swap our first diagonals, D and A, then change the B and C, which are constants, to be negative. So this is what we're going to use, D minus B, minus C, and A. Now, in this case, this is our A, B, C, and D. So we have our determinant as minus 2, 1 over minus 2. Our D is 4. Our B is 2. So since it's positive, it will become minus 2. Then our C is 3. It will become minus 3. And our A is 1. Okay. Now, multiplying this with this becomes 1 over minus 2. Okay, minus 1 over 2 times 4. And minus 1 over 2 times minus 2, and minus 1 over 2 times 3, and minus 1 over 2 times 1. So from here, we can see our matrix, our new matrix will become 2 here, 1, 2 into 2, 4. This will become minus 2. This will give us, minus will cancel minus, leaving us with 1. And this will give us a minus 3 over 2, okay? We can say 1.5, minus 1.5, and this will become a minus 0.5. So that will be our matrix. So we are having a minus 2, 1. Oh, sorry, this 3 is minus, so this should cancel. A minus 2, 1, 1.5 and minus 0.5, which is option A. Find the general solution to cos 2x equals half. Now, for this, our 2x will be, the formula for it will be plus minus pi over 3 plus 2k pi, where k is an integer. Okay, now for x to be alone, we have to divide both sides by 2. So this becomes 2x over 2 equals plus minus pi over 3 plus 2k pi over 2. Okay, so this cancels out, leaving us with x equals, since this is 2 over 1, inverse of it, we have plus minus pi over 3 times 1 over 2 plus 2k pi over 2. Okay, so this, our x, will become plus minus pi over 6 plus k pi. Right, in this situation, we are having it as plus minus pi over 6 plus n pi, where your n is your integer. So our answer will be option D. Evaluate integral dx all over x squared plus 4x plus 13. Now, before we do this, we'll first of all work out this using completing of square method, our denominator. So this becomes x squared plus 4x equals minus 13. Okay, so if we do this, this will give us x squared plus 4x plus 4 equals minus 13 plus 4. Okay, now from here we're having x squared, x plus 2 squared equals minus 9. So this will become x plus 2 minus 9 equals 0. So now we'll replace our original equation with this. So we are going to have it as integral of the x all over x squared plus 2, x plus 2 all squared minus 9. From here, our minus 9 going over should be plus, not minus. So this becomes this. Now integrating this, we'll find out that for our denominator of x plus 2 all squared plus 9, if we should integrate this, alright, this is going to give us 1 over 3, okay, tan inverse of x plus 2 all over 3 plus our constant c. Okay, now, so our answer for this of d dx of dx of x plus 2 all squared plus 9 will become 1 over 3 tan inverse, alright, of x plus 2 over 3 plus our constant. You know, integration is the opposite of differentiation. So this will be our answer, which is option A. If y equals x sine x, find the y dx. Now in solving this, we'll use our product law. And in our product law, we're having it as u dv plus v du. Okay, now in this situation, our u, let u equals x and v equals sine x. So our du will become 1 and our dv will become cos x. Now imputing this into our formula, we are having it as x, which is u, times dv, which is cos x, plus v, which is sin x, times du, which is 1. So this becomes x cos x plus sin x, which is x cos x plus sin x, which is our option B. Find the determinant of 2 minus 1, 3, and 4. Now, for us to find the determinant, we'll multiply these two together. Determinant equals 2 times 4. Now, subtract the multiple of this together, minus 1 times 3. So this becomes 2 times 4, 8, minus times 1, minus 1 times 3 will give us minus 3. So minus times minus will become plus. So this becomes 8 plus 3, which will give us 11. So the determinant of this matrix will be 11, which is option B. Solve x minus 2 over x plus 1, 0. Now, in doing this, we know that if we equate our denominator to be equals to 0, the equation will be undefined. And if we equate our numerator to be equals to 0, the equation will be 0. So for x minus 2 equals to 0 equals 0. So therefore our x equals 2. And x plus 1 equals 0. So therefore our x equals minus 1. So our equation will be x is less than 1, less than minus 1. Our x is less than minus 1 and x is greater than 2, which is our option B. Solve for x in 3 raised by 2x plus 1 equals 81. Now, to solve this, we have to convert 81 to be in same base power with 3. And in doing that, 81 equals 3 times 3 times 3 times 3, which is 3 raised by 4. So we will substitute 3 raised by 4 for 81. Now we're having 3, 2x plus 1 equals 3 raised by 4. So cancelling out our bases, we have 2x plus 1 equals 4. Alright, now collecting like terms, 1 going over will become 2x equals 4 minus 1. So 2x equals 3. So x equals 3 over 2. Alright, our x equals 3 over 2. And the answer isn't here. If sine theta equals 3 over 5 and theta is acute, find cos theta. So we are looking for cos theta, bearing in mind that our theta is acute. Now, since an acute angle is an angle that is less than 90 degrees, okay, so we can call this to be our theta. Now, from our Pythagoras theorem, we know that sine theta, or SOHCAHTOA, we know that sine theta equals opposite over hypotenuse, okay? And cos theta equals adjacent over hypotenuse, while tan theta equals opposite over adjacent. Now, bearing in mind this, our opposite will become 3 and hypotenuse will be 5. Alright, now on our right angle triangle, since this is our adjacent, this will be our opposite and this will be our hypotenuse. So our hypotenuse is 5, opposite is 3, adjacent we need to find in order to get cos theta. And in order to find the adjacent, we'll apply our Pythagoras theorem that states that hypotenuse squared equals opposite squared plus adjacent squared. Now in this case, our hypotenuse is 5 squared equals opposite 3 squared plus adjacent squared. Now 5 squared is 25 and 3 squared is 9 plus adjacent squared. So this becomes adjacent squared equals 25 minus 9. And 25 minus 9 will give us 16. Okay, now our adjacent will become the square root of 16, which is 4. So the value of our adjacent here will be 4. Now back to cos theta. Cos theta equals adjacent over hypotenuse. Now our adjacent is 4 and our hypotenuse is 5. So the value of our cos theta will become 4 over 5, which is option A. The function f of x, fx, equals x raised to the power 3 minus 3x squared plus 2x has a critical point at what position? Now, for us to solve this, we first of all differentiate this. If we differentiate this, this becomes 3x squared minus 6x plus 2. Now, having this as our new equation, we can now use our quadratic formula to solve this out. And our formula says x equals minus b plus minus root b squared minus 4ac all over 2a. Now in this situation, our a is 3 B is minus 6, and C is 2. Now, imputing these figures here, we're having it as x equals b minus minus 6 plus minus 6 squared minus 4 times 3 times 2 all over 2 times 3. Okay? X equals minus times minus plus 6 plus minus root 36 minus 4 times 3, 12. 12 times 2, 24. So this will give us minus 24 over 6. Okay? From here, we will now solve this to become 6 plus minus root 24 minus 6 will give us 12 all over 6. Now we know that root 12 equals 4 times 3. Okay, now this will give us 2 root 3. Now, substituting root 12 with 2 root 3, we are going to have our x equals 6 plus minus 2 root 3 all over 6. Okay, factorizing this, we are having x equals 2 bracket 2 into 6, 3 plus root 3 all over 6. So 2 here 1, 2 here 3. So our x equals 3 plus minus root 3 over 3 as the critical points of x, and our answer isn't here. Now it says find the range of fx of 2 sine x plus 1. Now we know that mathematically our range of sine ranges from minus 1 to 1. Okay, our sine wave ranges from minus 1 to 1. Now, bearing that in mind and imputing this becomes for minus 1, we are having it as, since it ranges from minus 1 to 1, this is minus 1 and 1. So times 2 plus 1. Okay, this becomes minus 2 and 2. Okay, plus 1. Now, opening up these brackets with this becomes minus 2 plus 1 and 2 plus 1. So this will give us minus 1 and 3. So the values of x, the range of x for 2 sine x plus 1 will be minus 1 and 3, which is option A. Find the integral of cos 2x dx. Okay, now cos 2x equals 1 plus cos 2x all over 2. Okay, now substituting this for this, we are going to have it as our integral will become 1 plus cos 2x over 2 dx. Okay, so this will, bringing out this fraction, we have it as integral of half 1 plus cos 2x dx. So this is going to become 1 over 2, 1 plus cos 2x dx. Now, integrating each of them, this becomes half bracket integral of 1 dx plus integral of cos 2x dx. Okay, now from here we are having it as half bracket x plus sine 2x over 2. Okay, we're having it as x plus half times plus sine 2x over 2. So now, multiplying through, we have this as x over 2 plus sine 2x over 4. Now remember, in integration we are adding our constant, okay? So this will become plus c. So the integration of this will become x over 2 plus sine 2x over 4 plus c, which is our option A. What is the solution to 2x minus 3 equals plus minus 7? Alright, now this would give us 2x minus 3 equals 7, or 2x minus 3 equals minus 7. Now, for this, going over, minus 3 going over will give us 2x equals 7 plus 3, 2x equals 10, x equals 10 over 2, which is 5. And for this, we are having it as 2x equals minus 7 minus 3, okay? Minus 7 plus 3, sorry. So our 2x equals minus 4, and our x equals minus 4 over 2, which will give us minus 2. So our values for x will become 5 or minus 2, which is option A. It says find the derivative of f of x equals in x squared plus 1. Now, first we say let u equals x squared plus 1. So our du, the x, will become 2x. Okay? Now, if we have in u is 1 over u, okay? Times our, so in u will be 1 over u. So our dy dx of our in u will become 1 over u times our du dx. Okay, so our u, recall that our u is x squared plus 1. So this becomes 1 over x squared plus 1 times our x, which is times our du dx, which is 2x. So this gives us 2x over x squared plus 1, which is option A. What is the solution to the inequality? We have 2x squared minus 5x plus 3, 0. Okay, less than 0. So now we'll solve out this quadratically, like turning this to 2x squared minus 5x plus 3 equals 0. Now using our quadratic formula, x equals b plus minus b plus minus root b squared minus 4ac all over 2a. Okay, where our a is 2, b is minus 5, and c is 3. So this will give us minus 5 minus 5 plus minus root minus 5 squared minus 4 times 2 times 3 all over 2 times 2. Alright, now this will give us 5 plus minus root 25 minus 4 times 3, 12 times 1 times 2, 24 all over 4. So from here we have 5 plus minus root 1 all over 4. X equals 5 plus minus root 1 will be 1 over 4. So our x equals 5 plus 1 over 4, or 5 minus 1 over 4. This gives us 6 over 4, or 4 over 4, which is 3 over 2, or 1. Okay? So, and 3 over 2 is same as 1.5, or 1. So our value of x will become x is greater than 1, and x is less than 1.5. Okay, so that would be our option A. X is greater than 1, or x is less than 1.5. If A equals, our matrix A equals 2, 3, 1, 4. It says find trace A. Now for trace A is addition of the main diagonals of your matrix. Alright, now in this matrix, this is our main diagonal. So this will become, our trace A will become 2 plus 4, which will give us 6. So our answer will be 6, which is option B. The sum of the infinite geometric series. We have 3, 5, 1.5, 0.75. Alright, since we're looking for the sum of this, we know that our A is 3, and our common ratio R, since the geometric ratio is geometric series, will become 1.5 over 3, which will give us 0.5. 1.5 divided by 3 will give us 0.5. Now, our sum of terms will become A over 1 minus R. Since our R is greater than 0. So this will become, our sum of terms will become A, which is 3, all over 1 minus 0.5, which will give us 3 over 0.5, which will give us 6. So the sum of the infinite geometric series will be 6.